Arthur Gibson here. This is my malware example 1. In this video, I am showing how to make malware, well, make mines stop, well, don't do anything bad, I should say. Um, yeah, so let's get into it. I'm using x64 debugger to reverse the malware example 1. So I'm going to go into the module. Going to search for current module to start by strings, so we know not running as administrator is the first string that appears in the entry point of the program, because this function is called, which leads to that string, which, you know, what I should have did was do this. Hold on. I'm going off video here, but it just annoying me. And I should have did that for all of these as well, but oh well, that's cool. Alright, so that's the first string of the entry point. We're going to go here, which leads us to the entry point function, which is the int main function, which is the start right there. This is the symbol, which I already did a comment of it, but yeah. This is the symbol code of it. We're just gonna play around here. We're gonna change the string. We're gonna change the string, simulating malware execution. Let's start by changing that string. Oh, no, I got select all of it. We're gonna keep size so the program don't crash. Malware fixed by Arthur Gibson. Brightness. Alright. Boom. So now that string will say malware fixed by Arthur Gibson, which is that first string right there. Now, so these are the functions that are called after this string appears on the command window, which is the bad functions, right? So we're going to simply see it's not being called because it's disassembled by the compiler settings, so it's just straight raw. So what we're going to do is simply, we can either set a ret instruction here that stops the whole program from running, or if we want to still display this here string and make these functions not get called, we can set a jump instruction right here. So we can set a jump that would jump to the end of this entry point code, which would be right here. Right here. Yeah. Okay. So, but the program might crash because instructions, assembly, and all that stuff, right? So, what's the best way? I got the best way right here. I got it. We're gonna just select all of this. Instead of doing a jump instruction, we'll just select all of this and select that binary field of notes. Boom. That's a lot of notes. So we'll set a breakpoint right here, F2, execute program, compile that stuff. Oh yeah, I previously had a breakpoint there. Let me remove it. Continue code execution, and it crashed as expected, but we changed string. So yeah, what else? Now let's analyze this malware just for fun, right? Malware. Let's go to current module and see the Windows API calls. No, I use dynamic APIs on this, so we can go string references, and we can note the code out, so it's not going to show. Let's go back to it. Reloaded the program so I can show it. Alright, there we go. So these are the Windows API functions I used for the malware, simulated malware. Yeah, so we can stop the beacon simply by, let's follow this in this simulator. We can stop the call to, better yet, let's see, jump. If I note this out, it'll crash, because then eventually the program will call it. So the RSI is in the open A. This jumps to, oh, boom. We just change that so we can change that to jump. So when this function gets called, which is the beacon function, it'll fail on all of this and jump straight to free library. So it doesn't do anything, right? So we fixed that part of the malware. Let's go back to references. What else this does? I'm trying to remember. What else I made it do? Registry. We can do the same right here. Yep. Jump. What else? Payload. Oh, one thing I noticed too, in this I forgot to dynamically get this here function. So it's not loaded via get procedure address. I'm saying get proc address, get procedure address. So we can actually just go to search for current module, intermodular calls virtual allocate. It's just that call right here. Memory allocation failed. Here right there. Yeah. That's it. So, yeah, that's it.